Alrighty, hello and good afternoon. Week 5 of office hours is live, and actually, Alexis, we have our first question of the week. Okay, so let's see. So for lab experiment 2, okay, and this is just for anybody watching or re-watching. This is a Chem 400 question. Specifically, this is for eLab 2. All right, so let's see. For lab experiment 2, problems 1 and 2. Okay, let's see. Let me just log into Canvas real quick. Alexis, really quick. Alexis, really quick, when you say problems 1 and 2, are you referring to the worksheets? Just so I make sure that I am referencing the correct thing. I'm logging into Canvas. To retrieve that. Okay, awesome. Oh, and problems 1 and 2 of the data analysis. Okay. Give me 1 second. Let me fire these things up. Okay, so I have all that stuff locked and loaded. Okay, so for problems 1 or 2, do you take your calcium acid and convert it to grams, and then take the grams and divide by the total? Ah, okay. I get your question. All right, so here's the deal. For the empirical formula, because that's what we're trying to calculate here. So the thing is, so we're going to have we're finding the empirical formula for calcium chloride. And calcium is going to have some subscript, which I will call X, and chlorine will have some subscript that I will call Y. And the important thing to remember is this X to Y is a ratio, and it is a molar ratio. Right? This is a ratio of moles. So to find the empirical formula, we need moles of calcium, and we need moles of, not moles of chlorine. All right? So the thing is, where we're going to get moles for both of these quantities, we're going to get them from our ISE reading. All right, and the ISE reading measures a concentration, right? So it's a concentration given in grams. Let me see, actually. Let me just double check the units. I think it's grams per liter, but let me double check. Oh, I was wrong. It's given in milligrams per liter. All right, so that's a concentration. That is a concentration, and yeah, totally. It's given in grams per milliliter. And so the way, so you have the IC reading, but you also know we're also given in the what's the thing called? The pre-lab, we're told the solution volume. All right, the solution volume for a solution of calcium chloride is 100.00 milliliters. All right, so with these two together, you can find the mass of calcium and of chloride. And then once you have that mass, once you have that mass, you can convert to moles using the AMU on the periodic table. So, for example, so that's kind of the general strategy, but let me give you a breakdown of how that calculation would actually go. So let's say, I don't want to do like anyone's explicit data set. Oops. So let me just work up a number real quick. All right. So, and let's say this is sorry, I'm just getting my data together, and then I'm going to do a sample calculation. Okay, here we go. So, for example, let's say we had a calcium ISE of 381.0 milligrams per liter, and we have a chlorine ISE of 595. Point 4 milligrams per liter. So, for example, if we want to do calcium, all right, so first we have 381.0 milligrams per liter, and we have a volume of 100.00 milliliters. Now, our first problem is right here. Milliliters and liters don't cancel, so we need to do a unit conversion first. We need to convert 100.00 milliliters to liters. All right, so we put milliliters in the denominator, liters in the numerator, and 1 milliliter is 10 to the negative third liters. So milliliters cancel. When you multiply 100 times 10 to the negative third, your calculator will tell you that the answer is 0.1, but we need the same number of sig figs. So this will come out to be 1.0000 liters. All right, so that is the volume we need to use. So we multiply this by 0.10000 liters. Now liters, or volume units, cancel. So we get, you multiply this through, that we have 38.10 milligrams, of calcium. But remember, what we want is we want to know how many moles of calcium we have, right? We need moles of calcium and moles of chlorine so that we can find the empirical formula. So we don't know how to convert milligrams to moles, but we do know how to convert grams to moles. So we're going to set up another unit conversion to convert milligrams of calcium to grams of calcium. 1 milligram is 10 to the negative third grams, and now milligrams cancel. Next, we want to convert calcium from grams to moles, so we put grams of calcium in the denominator, moles of calcium in the numerator, and calcium has an atomic mass of like 40 point something. Oh, here's mine, sorry. Looking for my periodic table. Oh. Here, hang on. All right. Yeah, calcium has an atomic mass of 40. Oops. 40.08 grams. Now, grams of calcium cancels grams of calcium, and we can crunch our numbers to find moles of calcium. So we gotta bust out our calculators. 38.1 times 10 to the negative third divided by 40.08 is 0.000. Let's see how many sig figs we can have. 49506 moles of calcium. All right, that is so that's our first number, right? That's our x, our moles of calcium. We need to repeat this calculation for chlorine. So now let's find our moles of chlorine, starting with 595.4 milligrams of chlorine per liter, multiplying by our volume, which we've already converted from milliliters to liters. So volume units cancel. This will come out to be 59.54 milligrams of chlorine. Now we need to take this mass, convert it to moles. Our first step will be converting milligrams of chlorine to grams of chlorine. So we put milligrams in the denominator, grams in the numerator. 1 milligram is 10 to the negative third grams. So milligrams of chlorine cancel. Next, we have to convert from grams of chlorine to moles. Put grams of chlorine in the denominator. And we're ready to crunch our numbers again. 59.54 times 10 to the negative third divided by 35.45 comes out to be 0.0016. Let's see, 4 sig figs. 80 moles of chlorine. All right, now we have our two numbers. All right, remember the whole point is we want to know what the empirical formula is, where we have X moles of calcium and Y moles, not of carbon, but of chlorine. We've calculated our values for each one. Our moles of calcium there we go. Our moles of calcium are 0.0009506, and our moles of chlorine are 0.001680. All right. Now we know that empirical formula, molecular formula always have to be integer values. So we have to make these integers. But this ratio, the important thing is this ratio is spot on. The ratio is correct. We just need to get these into integer values. The first step in doing so is you need to divide both sides, not sides, but both quantities by whichever is smaller. The reason for this is when you divide the smaller one, this is going to 0.000956 divided by itself is just 1. So it simplifies that. Let's see what our chlorine turns out to be. So 0.001680 divided by 0.0009506. All right, now this is not an integer value. Oops. It's 1.7673. Okay, now this part takes a little work. Because again, we've got to get this to an integer value, but we can't just round this up to 2. It would be incorrect to just round it to 2. You have to determine what fraction you're dealing with here. Yeah, no. It is totally okay. It is totally okay that your value for chlorine was smaller. Again, the data that we generated, the data set is not perfect, and it's not, so they won't all be the same. They're going to be different, and they're also not going to be correct. There's going to be a % error associated with each one, and you don't get graded on how correct yours is because you didn't even collect this data. It's, did you process it correctly? So totally fine that your chlorine value is smaller. It should be even. It should be different than mine. All right. Now, to get an integer value, you have to ask yourself, what fraction are we dealing with here? All right, and 0.7673, that's close to 0.75, which is 3/4. So what we're dealing with here is 1 3/4. Now, to get this to the empirical formula, we need to change this to an improper fraction, which 1 3/4 is the same thing as 7/4. All right? If you rewrite this as Ca1 Cl 7/4, we're almost there. The last step to get to integer values is we need to multiply both of these numbers in our ratio by our denominator, so it cancels here. So you end up with for my data set, you end up with 4 calcium and 7 chlorine. This is the empirical formula. Right. So Alexis, if your fraction is 1/2, so here, question. So in your instance, so did you come out with Ca1 Cl 1/2? Is that your ratio? Okay. Okay, perfect. Okay, so here, let me switch this around. So what you end up with is Ca. Yep, exactly. You get a 1/2 for calcium and a 1 for chlorine, and then you multiply this by 2 and this by 2 to get rid of your denominator. And so your final empirical formula ends up being CaCl2. And this is your empirical formula. Okay. Here. So let's dial it back. So you have Ca 0.49995 Cl1. Well, so here's my question. So let's dial back. What were the values you calculated for moles of calcium and moles of chlorine? Sorry, I think I left my office door open. I'm gonna go close it real quick. I can hear my family's voices eking through. Give me 1 sec. So Alexis, question. Correct. Correct. That is how you calculate the empirical formula. It is no worries. It is no worries. I'm down to work with you. Okay, well, okay. Here. Excuse me. Okay, so Alexis. Okay, so here's the thing. So when they're asking for the percent of each, they're asking for the percent mass, which is grams of calcium over total. And for chlorine, it's exactly the same, just different element. Now, the denominator for both of these expressions both of these are given in the data set. This was the mass of anhydrous calcium chloride. So that's where that number comes from, where your denominator comes from. For your numerators, so for both of these, we calculate them. And actually, we've actually already done this calculation. We actually just took it one additional step. So for your grams of calcium chloride, or sorry, for your grams of calcium, for example, take your ISE reading. So for example, mine was 381.0. This is milligrams of calcium over liters. We multiply by our volume, which is given in the pre-lab. So liters cancel. And then we got to convert from milligrams of calcium to grams of calcium. And 1 milligram is 10 to the negative third grams. So milligrams of calcium cancel. And then you can crunch your numbers. Your ISE reading obviously is different. 381 times 0.1 times 10 to the negative third. So this will give us 0.03810 grams of calcium. And then for grams of chlorine, you do the exact same thing, but just with your chlorine ISE, which mine was 595.4. And again, that's milligrams of chlorine over liters. We we multiply by our volume. And then we convert grams of chlorine. Or sorry, we convert milligrams of chlorine to grams. Liters cancel. Milligrams cancel. Oh, you are so totally welcome. I apologize for answering a question you weren't asking and all the ensuing confusion. That was my bad. Just for completeness sake, my value comes out to be 0.05954. These are grams of chlorine. And then you're off to the races with the equation for mass percent. Avinia, quick question. What lab or homework problem is your question coming from? Lab 2. All right, Nick, I see you have a question on step number 7 for the data analysis. Let me pull that up real quick. All right, use the actual empirical formula. Okay, let's see here. On what numbers to use? Oh, okay. Solid. And so for step 7, it says use the actual empirical formula for calcium chloride to calculate the expected. Okay, so for this step, for step 7, to calculate the actual values for the percent calcium, percent chlorine, so to get your actual percent masses for calcium and chlorine, you'll have to calculate these using the actual empirical formula, so based on CaCl2 and the fact that calcium has an atomic mass of 40.08 AMU and chlorine has an atomic mass of 35.45 AMU. And of course, taking into account the fact that there is 1 calcium and 2 chlorines in one molecule. So you use the empirical formula and each atomic mass to calculate and that's how you get your percent masses. So the mass of 1 calcium atom over the mass of the entire thing, the mass of 2 chlorine atoms over the mass of the entire thing will give you those percent masses. All right, Avinia, let's see. Problem 4 on data analysis. Let me pull it up. All right, so Avinia, question. Question: were you able to successfully calculate your percent mass for calcium? All right, so Avinia, so the thing with step 4 is you do the exact same thing, but instead of using calcium, you have to use chlorine. Um, so um, so that's all you do with that step. So step 4 may not make sense to you until you finish 1 through 3. So once you have the percent mass of calcium, then you're just going to do the exact same calculation over, but with your chlorine data. Oh, on the lab worksheet. Okay, sorry. I was looking at the data analysis. Hang on. Okay. Sorry. Okay, Avinia, I totally understand your question now. So the multiplication factor. So, for example, when I did this earlier, I came up with. Let me see if I can find it. Yeah, there we go. So when I was doing this problem, this was my right here. This is the pseudo-empirical formula right here with these numbers. And then I had to figure out, okay, I had to ask the question, what fraction is this, right? What fraction is this? And I realized that 0.7673 was about 0.75, which is 3/4. So what I really had was 1 3/4, which was this improper fraction, 7/4. And the multiplication factor the multiplication factor that I had to use to get from the pseudo-empirical formula to the empirical formula was right here. All right, because it's what I used to get rid of my denominator. Does that make sense? For question 7 on lab 2. Oh! Alexis, any one of these is correct. I take into account that there are slight variations within the periodic table, depending upon the one that you use. So it's totally any one of them is fine. Yeah. Um, oh, yeah. To get a to convert a decimal to a percent, you multiply by 100. All right, let's see. Alrighty, and I actually have to run because I have to teach a lab at another college on Zoom. So I'm going to close down our stream. Thanks to everybody who came out. There are great questions all around, and I'll be